Well, thank you guys for coming. Today we're going to talk about enhancing the projection in terms of our course demand projections. I am Alexis Pagel. I'm with the College of Liberal Arts and Sciences. I'm a management research analyst senior. So we do kind of data analytics tasks, and part of that is our enrollment management process as well. Our other Jason is here with me as well. Kim Beckert is on our team. She is the executive director. She supervises us on the data team. Unfortunately, she couldn't be here today, but Jason, you want to go ahead and introduce yourself?
Sure. My name is Jason Bradshaw. I am a management research analyst senior in the College of Liberal Arts and Sciences. And I work just like Alexis. We're part of the data team in the Office of Student and Academic Programs, which works directly with the Dean's Office. We report to Paul Lepore, the Associate Dean, who reports directly to Dean Patrick Kenny. So as far as projections and course enrollment management, I focus primarily in the online space for the online courses that we offer. And Alexis's focus is primarily on immersion, although we do a lot of cross where it's not mutually exclusive. There's a lot of cross, a lot of intersection. If we had a Venn diagram, it would just be basically one big circle. And in addition, we do a lot of ad hoc data requests. We're in the process of building out our data analytics site. Right now, we've got a lot of student-centric lists, but we're working on some interesting Tableau dashboards that have been requested by some of our units and some of our leadership. So we're hoping to roll those out in the next 6 months to a year.
So just a brief overview of the presentation today. We're going to go into kind of some background on our team and the college. And then we're going to review two different methods today that we're calling enhancements to what our course model projects. And then if anyone has any questions, we'll be going to that afterwards.
As many of you know, I know a lot of familiar faces in here, some I'm not quite as familiar with, and I'm terrible with names for some people. So the College of Liberal Arts and Sciences is the single largest college student-wise at the university. I think, I don't want to cause too much controversy. We consist of 19 departments. We have 90 plus majors, 25 plus thousand undergraduate students, although that's growing. I think that 25,000 is just immersion at this point. We're at the point now where some of our divisions, and we're divided into 3 divisions. We're unique in that respect. We have the humanities division, which comprises English, history, philosophy, we call them shippers, and then Silk, which is our School of International Languages and Cultures, natural sciences, which encompasses all of our natural sciences, including psychology, and social sciences, which includes things like geography and urban planning, School of Health. I don't remember. They're called SHESH. I'm sorry. I'm losing some of my definitions here. I'm not going to go through everything else, but you can look them up. We're the largest provider of general studies courses at ASU. So regardless of whether you're an engineering major, you're a WP Carey major, you generally will be as an emergency, you'll be taking our English 101, our math courses. So a large college plus a largest provider of general studies courses at the university means we have large data sets and reports. Our primary focus our team's primary focus and what we spend most of our time, probably 60 to 70% of our time, close to 80% this year, has been on enrollment management, which includes our course projections, working with units. And besides the data analysis team, we also have some other folks on our team. We have our DARS encoder. She's our senior DARS analyst. We have curriculum. Our team also deals with students' disciplinary issues. And we have 3 other folks on our team that handle those areas. And as everyone in here is aware who works with data, we've been the transition has been ongoing with this sheer number of reports. We had, I think at one point, probably 15,000 queries. We were able to reduce that down to about 1,500 queries we really needed to move from my reports. Some of those queries are very large, very detailed, and getting them into the new tools has been a challenge. It's also been fun. So obviously moving off of my reports to the BI tools such as Alteryx, Tableau, dbeaver, and obviously moving from Oracle to Redshift, and we have our own user database schema that we use to build some specialized reports that make pulling some of our larger data sets much faster for building some of our lists on our analytics set. Well, this is me. Okay. So as part of our course enrollment planning, which is what we are going to focus on today, there's so much that goes into course enrollment planning. Fall enrollment planning for us really is actually almost started for next fall. We have to start thinking about what new plans do we have coming. We're also going to start getting our admissions aspirational goals from the provost and admissions office, things like that. We already have to start planning. So by February or January, our models are already run for fall because fall enrollment starts in mid-February. So, and we're still in the middle, we're also still projecting for spring. For online, we also have to project for summer. So as the online projections analyst, I'm constantly working on online projections throughout the year. Alexis gets a little bit of a break, maybe about 3 weeks, but that's about it. As soon as 21st day hits, that's always sort of one of those dreaded days because you've maybe got that time frame where you can kind of relax a little bit, but then realize once 21st day hits, you've got to start thinking about the next term or the next 3 terms. And that's important with the number of courses. I mean, we have some of our courses have upwards of 6,000 or 7,000 enrollments that are required. And online, some of our courses have easily exceeded 5,000 or 6,000. And we're convinced that some of our courses, if we offered 10,000 seats, they would still fill. So it's a constant struggle, but so part of this process that you're seeing here is sort of the iterative process, the things we have to think about constantly. And some things you may emphasize, some things 1 year, some things are different next year. Online is especially difficult on occasion. There's a little bit more, I don't want to call it chaos, but we have to plan for new majors. And there's always, around fall 2021, when we had the slew of new natural sciences majors, which are heavy on our math courses and our natural sciences courses, and sort of understanding how to incorporate those into our projections can be difficult. And so we're going to show you some of what we do in that regard. So we've presented on our course projection model, which is just one piece of the puzzle. And we've got sort of a small summary here. And if you go back and look at from 2017, 2018, or wish to see our slides from there, please let us know. But our course projections model is really just basically, we have 2 main inputs. We have headcount and course enrollment. For immersion, the headcount piece is the most difficult. The headcount is what drives our enrollment projections. And so we get these aspirational goals from the provost office, and then we have to take those aspirational goals at the college and division level, flip those, and then sort of figure out how we translate that into, at the college level, freshman, sophomore, junior, senior enrollments. And that's probably the time we spend the most time on. And usually it can take upwards to 2 to 3 weeks. And those aspirational goals, sometimes we blow right through them. In fact, I think we did this year with one of our colleges where they were expecting 8% growth, and we ended up with what was it?
It was, I think, 5%, and it ended up at like 17.
And so when you're talking about English 101, which a lot of these, because and we're talking about goals for FYS, first year students. And so if those goals are really, our models expecting 5% growth, and we get, upwards of 20 or 25%, that's huge. And then our units have to plan for that. And then when immersion, it's not just about adding seats to a course, it's adding a section, it's finding a time, it's finding instructors. Letting them plan for the resources ahead of time, having them plan for the resources ahead of time is helpful for them, but it's not always dependable. So some of these slides are missing. because of one of our team members was unexpectedly out. So the primary thing that we use in all of our projections, immersion and online, is our course enrollment propensity. It's just a proportion. It's just a decimal or percentage or whatever you want to call it. And it's basically just we take our head count, we sort of divide it into whatever group we want to use that as our projection, as our input. Then we pull our course enrollment at that input level, at the group level. And then we define how many people from this group are enrolled in that course historically, divide that by the total number of people we're expecting in that group. So this depends on historical trends, historical enrollment from like the previous. So we're always comparing fall to fall or spring to spring. And in online, it's usually sometimes session to session. That's really all it is. And for ASU Online, for immersion, our input is our FYS and transfer but they're not the only ones that make up the enrollment in the courses. So that gets translated into at the college level, freshman, sophomore, junior, senior. We divide our course enrollment at the ASU Online level. We're not projecting headcount. We get those inputs from Ed Plus. And it's just basically it's the propensity for online is just looking at students in the various online plans and what proportion they make up of those courses. And then there's a bit more detail where we we do this at the 21st day, but we've got to back into those to like the day 8 level when students, what we call day 8, is sort of the day after ad drop, when courses are usually at their highest enrollment.
So once we have that main model projection, we essentially have numbers. So we can say our model would expect this number of students to want to take the course in that term. But the model will never be able to consider every single factor. So we have these various, what we call enhancements that can help us fine tune that number throughout the registration season. So these are things like us knowing if there are any new plans. So if we know the model wouldn't necessarily know that there's a new plan, a new major that requires this certain course. So things like that we can use to help fine tune that projection based on, projected number of students who are admitted to that plan, things like that. Other things are curricular changes. So if a prereq is dropped from a course or added to a course, those kinds of things our model would be blind to. So we would do that sort of analysis to help fine tune. 2 of these that we're going to be discussing today are going to be kind of the move on concept a little bit, in addition to what we refer to as registration cadence. So we're talking about looking at registration throughout the season and those kinds of trends. So that is going to be the first one that we are talking about today. So registration cadence is kind of that idea of looking year to date at registration in these high demand courses throughout the registration season. So a great example of this would be some of these courses that first year students take. So they're enrolling at ASU throughout the season. So if you compare that to an upper division course that's mainly taken by majors in their 3rd or 4th year, then you're going to see very, very different trends in enrollment when you look at that progression. So this kind of analysis, this visualization, can be used for some planning purposes, but it's mainly used closer to the end of registration when we're kind of visualizing for units what they can expect to see in terms of how they want to really allocate their instructional resources when it gets down to the end and they need to make these decisions. So the kind of data that we're using is snapshot course and student enrollment data. And some of the important things when we're doing this kind of analysis is being able to define what your week and day parameters are. So in the data, you have these week and day fields. And you have to decide, is day 8 most important to you, enrollment data as of day 8? Are you more concerned with 21st day enrollment or enrollment as of the add drop deadline? So those are the kinds of things that are really important to define in your data set. For this, we are focused on enrollment as of the add drop deadline. So add drop as of each of the sessions, which will look very different for session B. And then it's also important to define session and instruction mode, especially for online courses, because we know that A and B are very prevalent in online, and sometimes a course is only offered in a session A or a session B, or whichever one. So those kinds of parameters are really important when thinking about doing this kind of analysis. So session is one of our limitations that we put on this. So the first example we have here is a high demand immersion first year student course. So Math 117, we have limited it to session C. And you can see that throughout the registration season, that as of, we say, 4 weeks prior to the start of the term, there was only about 85% of enrollment at that point compared to what enrollment was as of the add drop date. So for a course like Math 117, that's a very significant number because of how much enrollment there is. That is around like 550 to 800 that were still left to enroll 4 weeks prior to the start of the term. So it's very important when we're thinking about talking to units. They're saying, well, our courses aren't filled. It's only 4 weeks till the start of the fall. You know, this course isn't full, so maybe we change it to a different room and reallocate some resources. And we can say, no, actually, at this time, you still should expect about 500 more students to enroll based on enrollment trends in the past.
And I'm sorry to not interrupt, but what you hope is that these projections are actually close to what the model is. So if the model missed these 800 or 500 students, we've got to find out why. So that's the other issue with this, and something we have to consider. We're hoping the model has already has accounted for this, but it may not.
So another example is instead looking at Math 117, but online and limited to session B. So you can see that if we were to cut it off at maybe 21st day of A or AC, then it would miss a lot of enrollment in your visualization. So paying attention to that, those sessions are really important in this kind of visualization. So this just kind of represents that ramp as well. So English 107 is a great example of a course where we've actually seen a little bit of a difference in these trend lines. You can see that as of about 4 weeks prior to the start of fall 22, there was actually only about 55% of enrollment as of day add drop. So that's a very significant amount. That was about 300 to 400 students who enrolled in those 4 weeks up to add drop. So with a course like this, and you see these trends, next year, we can look at this and say, you know what, we experienced this huge growth, but also why did we experience that huge enrollment in those last 4 weeks as compared to the last fall? So it kind of serves as a exploration tool in order for us to go further and look into things that maybe look a little bit different than past terms did. And also a great example of the difference in registration. So if you look at this compared to Math 117, you still see a lot of enrollment in those last 4 weeks, but this was a much greater percentage of total enrollment as of add drop. So these last 2 slides just kind of talk about the importance of session selection when you're looking at your data. So DAT 250 is a newer course. So we actually don't have a lot of data on it yet. So our model has kind of struggled being able to project it because it's not working on very much, as you know, compared to Math 117 or English 101, those things that we've been projecting for a very long time. So DAT 250 is one where we've really had to kind of develop these other ways of looking into how we project for this course. And also you can see that here, when it stops at, it was about 95 for fall 21 and about 135 for fall 22. That's because the course actually filled. And so when we're talking about using these trend lines, it's kind of as part of this bigger picture. Because if we know that this course actually filled, there was probably unmet demand in the course due to that. So those are all things that we would factor in when we try and go through some of these other methods of enhancing the projection. But also, this graph has both sessions B and C in it for immersion. So if you take a look at just session B, it actually looks quite different in terms of how it filled and those periods of when it experienced the most registration. So those are just some things. And as Jason and I have kind of already mentioned, these are ways of how we enhance what our model projects. So sometimes with a course like this, it might not necessarily work, but it does really demonstrate like, hey, like, look at this, your course filled, and you can see that if you were to maybe open a couple more seats or add capacity, then you could have possibly gotten more enrollments in it. But these are all things that we kind of factor into after our model projects it throughout the season. We're looking at these and saying, maybe like we can refine this better. So that is registration cadence in a nutshell. So as I had mentioned, it's a very useful way to visualize registration. So sometimes looking at these numbers, for me at least, it helps a lot to actually be able to see these lines. And it's also very helpful to visualize these courses that have a lot of registration throughout the summer, especially for fall, because units are looking at that constantly. And so those lower division courses that are mainly taken by fall FYS will fill much differently than upper division courses. And it really helps us communicate with our units about that process and kind of gives some insight into what we're looking at when we do projections. And as I mentioned before, this is an exploration tool. So it allows us to look into these things further and decide what changes we need to make. And ultimately, it's most effective when we use it with the other enhancements in order to kind of continue this continuous model projections process. So it's really used in conjunction with all of these other things. But it does have its limitations, obviously, with that DAT 250 example. So that one, it's not going to be able to effectively show you what those last couple of weeks enrollment would be because it was full. But courses are ultimately really affected by fall orientation, in orientation programming and changes in registration dates. So if they're moved back a week or if they're moved up, those year-to-date comparisons are going to be very different. So some of the things that our model or this enhancement would take into account is, for example, that spring semester when spring break was removed. We would need to make that adjustment in our data to account for that spring being a week ahead of all of the other springs in our model. There are also special cases when course policies are changed. So for example, this summer, we had to make the university made a course policy change because we were struggling to meet writing programs was struggling to meet English 101 demand because of how many new students we had coming in. So those kinds of things, when we look forward to the next few falls, are going to have to be accounted for in our model. And we're going to have to use all of these enhancements together probably to make those adjustments. But the last limitation that I just wanted to touch on is that it can be difficult depending on session and modality offerings to compare these things. So a great example is online, where if a course is only usually offered in session A, and then the next fall it's only offered in session B, when you're comparing those registration trend lines, they're going to be very different, because we know that registration for session B will last much longer than session A. So those are some of the other things to take into consideration. Go ahead.
Oh, sorry. I wanted to point out also with online that sometimes you have a course only offered in A or only offered in B, and then the next fall or spring it's offered in both. So then your model is already, the model projection for that course is already out the window, because you don't know, you don't have historical distributional breakouts for those. And there are a host of other things you have to look at, and that's especially difficult. And then you have to start looking at sort of what the enrollment, those, like what she was talking about, you model that as sort of whatever kind of time series regression you might have to sort of figure out, what do we think it's going to be based on how it's progressing now, hoping that the course doesn't fill up. Because if you see that flat line, then you can't even do that, because you've lost all of this information, because your course has been full for 5 or 6 weeks. And online, we've seen that quite a bit, where we see courses that fill up within the second or third week of registration when online starts. And I struggled with that with a couple of courses for spring. It's like, and then they're not in the model because they're fairly new. There's a lack of information. There's all these new majors that are taking this course that aren't accounted for. So that's the other thing too. Go ahead. Sorry. Oh, okay, I guess I'm next. Okay, so the second enhancement we look at, and something that I think is interesting to a lot of people, is how can you model move-on rates? How can you model projections using move-on rates or retake rates? And so for this example, I think one good sequence to use is Math 265, 66, and 67. We're not using the 270 series because 65 and 66 and 67 are only offered online, and then they offer then it's also offered in immersion. And again, this is typically used after model projections, and unlike the registration cadence or enrollment flow, we can typically look at this right away. And in the immersion space, we'll sometimes look at this when looking at fall to spring courses for first year courses that have prerequisites, like English 102 has a prereq of English 101. Math 266 is a prerequisite. 265 is a prerequisite for 266. So these are interesting ways to look. They're not always dependable. And I kind of got a little fancy here, and I mentioned Markov chain in the title of Markov models. It's actually much harder than you would think to model these correctly. You have to be very, very specific with your data. It's not going to meet the technical definition of what a Markov chain is. And those of you who are unfamiliar with that, let me know and I can forward you some references. And I'm not going to go into the technical details. But I found out really quickly that you can't model a lot of courses together. There are certain courses, it has to be almost a linear progression. You can't have courses that maybe, like an example is Math 243, where 265 is a prerequisite, but they don't always take it in that sequence. Or if they take 243, they're taking 2 or maybe 1 or 2 other math courses at the same time. So that will violate a lot of the requirements that you have to sort of build this, what you would consider a statistical model. And the Markov models really are used for multi-step processes, but we're only looking at one step, like fall to spring or spring to summer for online, or session A to session B for one term for online courses.
So if you're using the end of term data, doesn't that crunch your timing? Because you need to have your projections like mid-session, I'm assuming.
Well, we're looking at historical end of term data. So if we're going to project for fall, like for spring 22, for example, and that's the example I'm going to use here. we're projecting for spring 22. So we're using the move on rates from fall 20 to 21, or even going further back to compare the move on rates to see if they've changed. For online, that's important because the move on rates can sometimes be all over the place. A lot of things can be all over the place for online. In immersion, they're a little more stable. And fall 20 was a little dangerous because of the obvious issues we've had in the last couple of years. So, but it looked like when I didn't want to do our spring 23 projections because we're still not there yet. And so I wanted to have some end of term data that we actually had real data on.
So like for spring 23, you wouldn't use fall 22 because it's too late.
No. You're applying the fall 21 to spring 22 move on rate to the fall 22 enrollment data. And technically we have end of term enrollment data now because really right now after add drop, it's just we're including withdrawals, which also presents still some interesting things I ran into. I noticed that like you've got these withdrawals, but I was like, why do I have duplicates in 266 or 265? Students were enrolled in two sessions at one point. They withdrew or had a late withdrawal, or they've had administrative withdrawal or administrative drop. And so the data can be really, you've got to really look at your data and sort of analyze how you want to count, because if not, then you're going to run into all sorts of issues. So here's an example of what the Markov chain for the 265, 66, 67 looks like, modeling fall 20 to spring 21. And as you can see here, for Math 265, the circles around each of these are called the states. And this is actually a good Markov chain. This is one of the only course sets I could use that actually worked. That's the other issue. And it took a lot of trial and error to find out which ones worked the best. And I thought modeling more than just two course pair was more interesting. So for Math 265, the circle around each of the states are those students who retook the course. So this 0.1041 for Math 265 means of all the students enrolled in fall 20 Math 265, about 10% of them retook the course the next spring. Then the blue line moving from 265 to 266 tells us that about 60% of the students moved on from 265 to 266. Then we have they didn't take any of the 265 the next term. And so all three of these courses are all moving, they didn't take the next course, either because it's a terminal course for them or they just didn't take it. And in fact, these numbers are much lower for online and much more problematic when you look at session to session. Considering how the major maps are structured, you notice that a lot of students do not move on directly from 265 to 266 in online. And I don't have the model matrix up here. I didn't want to sort of get too technical, but if you're interested, I can share some of that data with you. So this is for immersion. And then if I look at fall 20, fall 21A to fall 21B move on rates, you can see the rates are much smaller. Approximately 4% of Math 265, they retake it in B after taking it in A, and only about 6% move on to Math 266. But you can see 86% of Math 265 don't take the next course in the sequence. And you also see you've got a line from 265 to 267, about 4% of our students actually move directly onto 267 in B for various reasons. Why, we don't know, but in this case it works, but you can model that. So what do we do with this to sort of figure out our move on rates? So it's really not terribly complicated. It's just a little bit of arithmetic. So basically to estimate our spring 22 enrollment in Math 266, we would use the fall 20 to spring 21 move on rates or retake rates. So for Math 265 to 266, the move on rate was approximately 0.6. We apply that to the fall 21 Math 265 enrollment, which is what we had the end of term, which is the 1,312. Then we also need to consider the Math 266. And then we apply that move on rate to the 266 enrollment in fall, which was 791. And we estimate that approximately 853 of these students will occupy 266. But is that the solution to our problem? Do we think it's going to be 853? Anybody know if that would be the end of the projection, or is there anything else? The answer is no. Because if we look at spring 21, what proportion of the spring 21 enrollment do those students typically make up? They're either retaking it or they're moving on. It's not always apparent. You have to look sort of the other way. So historically, we're looking at like spring 21. So what proportion of the fall 20 move on and retakes made up the total enrollment in spring 21, 266? And the answer is it's about 86% for 0.8568. So that's pretty good. So you're only missing about 15% of your enrollment. So you could just take that projection of 853 and divide it by the 0.8568 and get the 996. Our actual enrollment was actually 1,043, but there's a reason for that. There's something we're not accounting for here. And in immersion, that's kind of a big miss. Because in immersion, that could mean a whole new section or a larger room, could mean another instructor, another meeting time that maybe doesn't, and when students are sort of at the end of registering, that could be a huge imposition on pretty much everyone involved. So part of the reason before we get into limitations, and I'll discuss what I was just talking about. The benefits are, it's a useful way to examine how students are moving from one course to the other in a course sequence. And we can apply it to other measures like head count. Like our head count input for our model projection for immersion, this is exactly what we use. Except we sort of flip it from our FYS and transfer and look at that in terms of, we translate it into freshman, sophomore, junior, senior using just regular census data and looking at the move on rates from one fall to the next term, and you can use it for retention. And some of you who may have been to some of our previous presentations on swirl, students moving between majors, and sort of some of the visualizations we're working on for that. We do a lot of this. For course enrollment projections, it's good if it's a limited view, but it can provide you some additional information. And again, like Alexis mentioned, sometimes our models just don't pick up the course information for various reasons. It's especially difficult in online because of all the new plans, especially with the slew of new natural sciences plans, psychology, new souls plans, large demand. Some of these plans just grew from like 100 to 1,000 from one fall to spring. And our model is not going to pick that up within at least the first year. The online model can be very, very sensitive to that. And sometimes it doesn't pick up some of these changes for quite a while because the head counts just grow so quickly. Again, curricular course changes. An example is we used to have a Bio 281, 282 majors only course. They eliminated that a couple of years ago. And so everybody takes Bio 181 and 182 now. So our model in immersion doesn't pick that up. So we can use these to sort of figure that out. There's others, and the 281, 282 don't exactly correlate together. They're actually reversed in the content. So 281 sort of translates to 182 and vice versa. So that made things a lot more difficult.
On the previous slide, you missed by about 4%. You said, so is that outside of your bounds? Is that an okay miss? Does it depend on the course? Like, what's your take on that?
It depends on the course. For online, a 5% miss, I'll take it. I think for immersion, it can be a little bit more difficult. A 4% miss in immersion, I don't know. Do you guys? I mean, we haven't really discussed that too much, but I mean, it just depends, I think. Do
you guys have a batting average? Like on average, we are minus 2.1%, and like, how did we do this semester? Like, do you actually like keep your stats?
We've started that, but we haven't been able to finish some of that analysis because we always start it and then something else sort of overtakes that. But I think initially when I first started doing projections for online, which is about 5 years ago, I was pretty off. And then once I learned more of the data warehouse, I learned how to sort of use this data, as I've actually gotten better. It's usually between 5 and 10%, depends on the course. And I think for immersion, we're a little more accurate because we dig a lot more deeply. So I imagine it's around, I don't know. I don't want to.
On average, are you under or over? I know, there's pros and cons of going either. Do you tend to swag one way or another?
You want to give an example?
I mean, for immersion, there are certain courses that I can see that our model consistently under projected for a couple of terms. So those ones are ones where I'm looking at more, and I can look at that and say, maybe we should buffer this a little bit this year. But the other thing is, when we're talking about immersion, One of the interesting things that we actually hope to do is put what our ending growth is in the model instead of those aspirational estimates, to see if we knew everything, how accurate would this model actually project. So that's one of the things that we're hoping to do as well, to see if we knew all of this stuff, what would our average be? So.
And with online, I think over projecting is better, because with ASU Online, if they need to add a new section of 50, they can and let's say they're offering 4 sections of 265 at 100 seats each. And we say, oh, you're going to need about 50 more seats. And they've been full for 2 weeks. They can add a seat of 50, maybe because it's a grad assistant, there might be a cap on the capacity. They can rebalance their sections in a way that the teaching loads are equalized, because you don't have to worry about the student's meeting pattern for that course. You don't have to worry about it. So online, I like to overestimate more than underestimate, because there's a bit more leeway. There still is the resource issue with instructors, but I think with online, I would rather be over than under, because then again, there's a lot there. They can use more tools to balance things out after the facts. Now, if you're trying to balance out Math 117, which has upwards of 5,000 or 6,000 enrollments in a term, that's a lot of work for someone. But typically, I would rather be over and online. Immersion online can be different, but it also depends on the course. It's really course dependent, and I think that's one of the things. That's why our English composition, we spend so much time on it, because it's such an important. It's probably the most important sequence, first year sequence for most students. And it can cause a lot of issues, because you really, sometimes it's like throwing darts at a dartboard. Sometimes it's great, but we do a lot more English composition and immersion. English composition is not a huge deal for us in the college, because we don't offer 101 and 102 and 105. So I get out of that online. I get out of that. So but yeah, and then again, the whole thing with changes to major maps that can also affect our model projections and some of the other things that she touched on. And with ASU Online, again, it's the introduction of new majors. Can only really be, so the limitations are, you can really only use these on courses with prerequisites. You can maybe try if you know that a course is consistently made up of certain populations. You just have to change what you're doing. We're not looking at plans here. We're just looking to circulate course enrollment from one term to the other. We're not getting to the unit, the college, or the plan level in any of these. And move on to retake rates, like you saw for online, don't always represent a large enough amount of course enrollment to make accurate predictions. Usually our threshold, if it doesn't make up, when I illustrated that looking the other way, if it doesn't make up upwards of 85 to 90%, we actually have to do different analysis. We can't use a 7% move on rate and say that's our projection, or a retake rate, a 5% retake rate, and say that's our projection. It's never worked. And so there's always a lot more digging if you're going to use these. And a lot of times with online, it's just used to maybe validate some of the projections. And can be tricky with courses that don't follow a strict linear progression, or students may take, or you've got to limit the courses where students can't take 265, 66, and 67 in the same term, technically. There are exceptions, obviously with online with the A to B, but even with I courses in immersion, because some of the examples are, I had to restrict this to only looking at in-person C-session courses from fall to spring, because otherwise I would have students taking 265 in person in fall, then moving on to 266 and 267 I courses in A and B, and then that violates the entire definition of what I'm trying to look, the statistical definition of what we're modeling. Now you can do it if you don't care about that, and we're not really doing long range predictions. We're just looking at it from one fall to spring. So that illustration, you can use it. It just won't be a true Markov chain or Markov model. And it's really best at looking for pairs of courses or small sequences. So like 2 or 3 courses. But again, you've got to be aware of a lot of the restrictions that you need to impose on your data to make this work. So, and part of what I was going to touch on, and I forgot to mention here, is that 1,043. Remember, I only looked at C-session in-person courses, but 266 is offered I-course. I didn't model that here. So that 1,043 is probably taking into account, or is taking into account the I-course that I didn't model. So you would have to build a separate model for that and analyze that separately to get the I-course. Unless somebody has, now I've only spent like a couple of days on this, so if somebody has a different way or has any suggestions, feel free to reach out. I'm happy to take some ideas or discuss any of this. Oops. Sorry, going the wrong way. Okay. Questions or discussions? In discussion?
So you're saying that for a lot of it is just to use at the end of term or end of session data.
Mhm.
And you said that you're going to start working on fall 23. But the thing I think one of my students kind of, I wonder because the fall 23 schedule
Mhm.
is due this Friday.
Oh,
How do you use that to project using using this semester data for next fall when we're right in the middle of it, but
Sure.
next fall is already due this Friday.
sure. Yeah.
So like I said, I'm just trying to reconcile this whole.
Yeah. These enhancements we talked about generally don't happen right away, especially for our fall enrollment, our fall 23 projections. Again, we won't run our fall model until like late January, early February. But but we will know, we still won't know the move on rates, at least from the move on point of view. We won't know any of that until the end of spring, right? So so for fall, since our fall model is a little bit earlier, because we've got that large 25, 26 week enrollment period, we don't generally do that for fall. This is mostly looking at fall to spring because it's a little more dependable, or spring to summer for online. Although spring to summer online is still, because summer is a thing in online. And students should be taking the courses, although you see a sharp drop off in enrollment in summer anyway in the online space. So yeah, typically we won't use move on rates for fall. Usually if we get to fall and we're looking at maybe a move on rate for like the 102 enrollment for fall 102, we'll look at that for English or something like that. But we typically won't look at it for the fall model that early. For fall to spring, we can typically look at this almost right away because we're using historical data from the previous year or previous years to either average out the rates or figure out if there's a trend in the rates, either increasing or decreasing, to apply those. Makes sense? Hope I answered your question. Okay. I didn't want to give a politician answer, but I may just have.
Data you use from the college versus the other schools and colleges.
Yeah.
I imagine for things like for FYS courses, that's across all the schools. After those, to get most limited just students with plans in the college, or do you still have from all different plans in schools and colleges?
These are only our courses offered by us. And so it's blind to where these students are coming from. So again, like with 265, 66, and 67, those are the engineering, that's the engineering calculus sequence. So most of those students are engineering students. And then online, it's everybody that has to take these courses because
you have to communicate with folks in Fulton Engineering to understand details about plans and enrollment, or can you tell that from the data, or both?
Specifically when we're talking about immersion projections, we do a lot of, we talk a lot with other colleges. An example would be, we noticed last summer during registration that there was this huge decrease in one specific population year to date in enrollment. So we actually contacted them to see like, hey, did you make advising changes? What happened? Because we're noticing your students aren't enrolling in this course anymore. So those are things that we talk a lot with other colleges about. And we do a lot of, when we're talking about enrollment flow, which is kind of another enhancement, we're looking at, we can also drill down to the plan level so that we can see if there's any changes in course composition at the plan level. So we know that maybe student behavior is changing, or there's curricular changes or advising changes that we missed. So those kinds of things we do a lot with at the plan level too.
There's a possibility, but some of those are very difficult to sort of put into the model the way it's built. And our model right now is very effective at predicting for most of the courses that we needed to project for. So we sort of enhance the projections with those additional steps because it's just easier and it saves a little bit more time. It would probably take us a lot longer to build the model the way we want it than it would be to just sort of do these additional analysis ad hoc. Plus, I think if we do this after the fact, we get a deeper understanding of like she said, like who's making up our courses. Like we've had units reach out to us, why is our enrollment in this course cratering? And then we'll go and we may not be aware that this course is no longer, they're advising their students to take a different combined course that's combined with that course. So there's lots of different factors that can play into that. And we could try to build the model in a way to take all those into account. But I think there's so many that would almost be intractable because we can't do it. We have upwards of 150 courses that we project for. Not all of them that we pay attention to, but they've been added over the years. So we have some 400 level courses we do online. We have some 300 level courses. But most are 100 and 200 level, with the emphasis mostly on 100 level courses.
And about the capacity planning, how
Mhm.
early you start to work on the capacity planning?
You want to answer that?
So units will, like she said, submit their schedules for fall now. And I think there's some like general recommendations that they have unit by unit of how much they build for the fall. But we will start our projections, like Jason mentioned, in January and February, and then we continually monitor those to recommend maybe increases or decreases in what they have built in capacity throughout February all the way until the start of classes.
One thing I also want to add for some of these projections is that some of you are familiar in this class schedule we do a lot of block enrollment in fall for our fall immersion courses, but lots of other reserves as well that can also affect some of this. So we've had to untangle some courses occasionally that were full, but we realized these reserves just weren't filling. So that can also affect some of what you're seeing here. Some of the reserve capacity, we take that capacity out, that's not counted. If those reserves aren't full, but that's out of the capacity because it's not for the general population. We're expecting those specific students in that reserve that are targeted in that reserve to enroll. And when they don't, that can be a problem as well. And I think I ran into that with one of our online courses this year for fall B, actually.
I know time's up, but
Hmm?
how are you presenting it in a dashboard and are there just notes with all these additions and like that account for this and that? How does the end
You want to?
person receive all this?
For immersion specifically, we have kind of like our main course projections spreadsheet that I continually update that pulls data that we run. We're planning on building this kind of registration cadence process in Tableau so that we can have a more interactive dashboard for units to use to actually see, do their own research and kind of exploration into these courses. But a lot of these, we communicate projections via like an Excel document that we continually update for units. And then we kind of include just our analysis. We kind of summarize all of these different factors when we tell them why certain projections are changing. And we are planning on building some, and then some are just more kind of like exploration tools for us to determine like justification for our projections. So
Same for online. We have these specific, what we call distribution documents that just have summaries with our updated projections, previous projections, current capacity and enrollments, historical capacity and enrollments. And then again, if we notice something that's different that we didn't catch the first time, or something's changed from what we thought because something else is happening, I'm being vague, then we will outline that in the email. So we try to give as much analysis, but we don't do a dashboard because this is not really at the leadership level. This is at the scheduler and the director level within the units. So we're really depending, we work closely with the schedulers and some of the department directors and some of the other faculty that oversee some of the enrollment management, either at the undergraduate, either through immersion and ASU online. Some of our departments have separate immersion and ASU online because they're so large. Thank you, guys.
Awesome, thank you.